Alright, so this tutorial is to explain how to do source transformations. And you can do source transformations two ways: a current source transformed into a voltage source, or a voltage source transformed into a current source. So basically, I'm going to start off with teaching you how to do a current source being transformed into a voltage source. Now, when a current source is going to be transformed into a voltage source, there's two requirements that have to be attained. First, the current source has to be in parallel with the resistor, and there must not be anything else in between that. So you can't have another voltage source in series with the current source. It just has to be just a current source in parallel with a resistor. Now, if you don't know what in parallel means, it's basically, let's draw a circuit here. And let's say the circuit splits off into two branches. And basically, these two branches join together again. So this circle and this circle, they are in parallel with each other because the branch is basically parallel and it joins back together again. It splits off from the same starting point and it joins together again in the same starting point. And now let's make this a complete circuit by joining it together. So this will actually look like this. Alright, and this right here is what you will mainly see. Just something that looks like two boxes together. Because as you see right here, the line here splits off into two and then joins back together. So it splits off here, joins back together here. So right here and right here, these two are in parallel, or these two red circles are in parallel. Alright, so basically that's what in parallel means. And actually, we can go a step ahead and say that these three circles are all in parallel, and that's only true if there's nothing here, and there's nothing here, and there's nothing here, and there's nothing here. If there's nothing here or here or here or here, then these three circles are in parallel. Alright? So, okay. Let's get started. Alright, so I'm going to show you how to do a voltage source into a current source into a voltage source. So I'm going to draw a current source, give it 3 amps. And draw a resistor, make it 3 ohms, and put these two things in parallel. Alright? And to transform it into a voltage source is pretty simple. All you have to do is multiply the current source and the resistance together. So you get 3 times 3 equals 9. 9 volts. And the way you draw the voltage source is whichever way the arrow point is pointing on the current source is where the positive terminal is on the voltage source. So in this case, the positive terminal is on top because the arrow is pointing in the upwards direction. So whichever side the arrow is pointing at is where the positive terminal is. And this will thus be the negative side. And now we keep this resistor and we put it in series. with the resistor, with the current source, my bad. So the resistor and the voltage source are now in series with each other. So this circuit right here is the same as this circuit right here. Alright? And as you see, this circuit actually is more complex than this circuit, so you are already seeing how source transformation can make a circuit simpler. Alright. Now with that said, I'm going to show you guys how to make a voltage source get turned into a current source. And there's also two requirements. There has to be a voltage source and a resistor, and the voltage source and the resistor have to be in series. And if you don't know what in series means, they're just along the same line. So this circle and this circle right here is in series. But if we add in this line right here, they're no longer in series. Alright. So, with that said, let's draw a current voltage source, say 3 volts, and put it in series with the resistor 3 ohms. Okay? And this works the opposite way. You divide the voltage source by the resistor, so 3 divided by 3 equals 1. And this becomes a current source. And the way you draw the arrow is whichever side the positive terminal of the voltage source has it, is whichever way the arrow is pointing on the current source. So in this case, the current source is pointing up because the positive terminal is on top. So whichever place the positive terminal is on, whichever side is on, is whatever way the arrow is pointing. And now we have to keep the resistor. This right here is 3, and we put it in parallel with the current source. So this is 3 amps. Alright, so these two are the same circuits. And you're probably thinking, why would I ever do this? Why would I ever make a voltage source turn into a current source and make the circuit more complicated? Well, right now, actually, I'm going to show you that. I have a circuit prepared for you. So here we have a more complicated circuit, and we're going to make a series of source transformations to take this circuit right here and turn it into a more simpler, better looking circuit. So let's just take a look at every independent source that we have on the circuit and see if we can transform it into something to our advantage in order to make this circuit simpler. As you see here, let's take a look at the 2 amp source. The 2 amp current source is in parallel with the resistor. So we can transform this 2 amp source into a voltage source. Now, just in case you might have been wondering, if there's a resistor right here, we would not be able to do this source transformation. There has to be nothing in between the current source and the resistor. It has to be just the current source and the resistor in parallel. There has to be nothing in between. No voltage sources or resistors at all. To our advantage, there is nothing in the way, so we can go ahead and do the source transformation. So recall that to transform a current source into a voltage source, all you have to do is multiply the resistor and the current source together. So 2 times 6 is 12. So this becomes 12 volts. And we're going to make this arrow disappear and change it into a voltage source. Since the arrow is pointing up, the positive terminal will be the side the arrow was pointing at. And this resistor disappears because we have to move it now in series with everything. So basically, the resistor, the 6 ohm resistor, is moved in series with the voltage source. So it becomes right here. Now, it doesn't matter which side of the voltage source you put the resistor on. You could put this voltage source right here, over here, if you wanted to. It doesn't matter. It just has to be in series with the voltage source. But I'm going to put it there because I want to be able to add these two together. So we're going to just add these two resistors together. Recall that when two resistors are in series, you can simply add them together. So basically, these two resistors become 12 ohms. Alright? So we made the circuit a little bit simpler over here. Let's take a look at this 1 amp source. We can't do anything with it. There's no resistors in parallel with this thing, so we're just going to have to leave this source alone. Let's look at this voltage source. We can transform this. But you're probably wondering, hey, why would we transform this voltage source into a current source? Wouldn't that make the circuit more complicated? Well, in a few steps you'll see why I'm doing this. So basically recall that the voltage source transformed into a current source is basically the voltage source divided by the resistor in series. And there has to be nothing in between these two things. So if there was like a, if there was a resistor between this, we could just add it into one. So there has to be nothing in between here. So for example, if we have another branch here, these two things no longer become in series. So thus, we can't do the transformation. But to our advantage, there's nothing in the way between the resistor and the voltage source, so we can go ahead and do it. The voltage source divided by the resistor is how we get the current source. So it's 34 divided by 17 is 2 amps. So this becomes 2 amps. I'm going to change this voltage source into a current source. Recall that the positive side was on the bottom, so the arrow will be pointing that way. Alright? And now we have to put this resistor in parallel with the current source. So we can put the resistor here, or we could put the resistor here. It doesn't matter what side we decide to put the resistor on. It just has to be in parallel with the actual circuit. Alright? So thus, I'm going to actually put it on this side. So the 17 ohm resistor is now here. And now we can simplify the circuit because we can combine these two resistors because they are in parallel with each other. And now recall that when you have two resistors in parallel, you can actually combine them together. And we take the 17 ohm resistor, we add it with the 1.5 ohm resistor, and the way we add them is we put them in inverses of each other, and then we add them together. So basically we have that, and then I don't have a calculator right now, and so let's just say this was equal to A, and then to get the final answer we have to put A and we have to turn it inverse again. So the two resistors added together in parallel is equal to 1 over A. So let's erase these two. Now, if you're not familiar with with how to add resistors together in series or parallel, I recommend you watching my video over that before you watch this video, because this might confuse you. I'm only doing 1 over A because I don't have a calculator. Like I said, you would get a number answer if you added these two resistors together in parallel. But just for the sake of me not getting up and getting my calculator, we'll just say this is 1 over A. And, okay. And so, let's take a look at this again. And let's see if we can transform this any further. From the looks of it, no, we can't make this circuit any more simpler. Well, actually, yeah, we can. We can turn this current source right here back into a voltage source, and you're probably wondering, why the heck would I do that? Well, we would get rid of this line right here, so let's do that. So recall that a current source into a voltage source is basically this times this, so 2 amps times the resistor would make it into 2 over A volts. Alright, and this simply disappears now. And recall that the resistor was 1 over A, so we have to put the resistor in series with the voltage source. Before we do that, I'm going to actually change this current source into its respectful voltage source. So, bam, right there. And, okay, and the current source, the resistor, we have to add it on. It doesn't matter which side we decide to put the resistor on. We could put the resistor here, but I'm actually going to put the resistor here. But it doesn't matter where you put it, just wherever you think is the best place to put it. So this right here would be 1 over A ohms. Okay. So yeah, I guess that's pretty much all you can do with this circuit in terms of transforming it into a simpler one. So yeah, and this is very useful when you're trying to get the Thevenin or Norton equivalent of the circuit, or as you move on to more advanced topics, source transformations is a crucial tool that you need to know how to do. So I hope you enjoyed this video, and if you have any questions, please ask, or just read your textbook. Thanks.